Good morning, all. Welcome to third lecture of Unit 4. Today we are going to discuss about the essential requirements to build up the leisure life, that is leisure construction. So in today's class, we are going to discuss about pump source, gain medium, population inversion, optical cavity, and so on. These are all the requirements to produce the leisure light. So first one is population inversion. So population, you have to remember that the number of atoms or electrons or molecules present in the ground state or in the excited state is called as population. So usually in any of the system, the number of atoms present in the ground state will be more than the number of atoms present in the excited state. But in order to get the laser light where the stimulated emissions plays an important role, we have to revert the population. Means we have to invert the population state. Inverting the condition is nothing but N2 greater than N1. N2 is nothing but the population in the excited state. So to get the laser light, we have to get the inverted state of population. That means excited state should have more number of atoms or electrons when compared to the atoms present in the ground state. So here these, suppose if these are considered as the number of atoms, usually N1 will be more. N1 is nothing but number of atoms in the even state, and N2 is number of atoms present in the excited state. So usually N1 will be greater than N2. Radiation is mostly absorbed when spontaneous emission dominates. But when we see the laser light, stimulated emission should be predominant when compared to the spontaneous emission. So if N2 is greater than N1, means most atoms occupy level E2 and there is a weak absorption, stimulated emission prevails and light is amplified. That is known as population inversion. So how will you get that population inversion? Population inversion is nothing but more and more number of atoms should present in the excited state. So a state in which a substance has been energized or excited to specific energy levels. More atoms or molecules are in higher excited state. And the process of producing a population inversion is called as pumping, the next requirement. So in order to put the more number of atoms in the excited state, we need to excite the system, means more and more energy should be given to the system so that the atoms in the ground state absorb the energy and they go to the excited state. So in the case of pumping always depends on in which medium we are getting the laser light. Suppose if it is a solid laser like example ruby laser, we need to go for the xenon flash lamp. And if it is a liquid laser like, if it is a gaseous laser like helium neon laser, we need to go for electrical discharge. And if it is a semiconducting material, then we have to go for the recombination of electrons and holes. So you should remember that in this point we have discussed there are three types of lasers. Solid lasers, example is ruby; gaseous lasers, example helium neon; and third one is semiconductor diode laser. Semiconductor we have already discussed in third unit of optoelectronics. So in this unit we are going to discuss about the ruby laser and the helium neon laser. So pump source is nothing but pumping is we need to provide energy to the laser system. So electrical discharges, flash lamps, arc lamps and chemical reactions are few of the pump sources. And the type of the pump source depends on the gain medium, means the material from which we are getting the laser as an output. So in the helium neon laser as discussed, electrical discharge is used. Radio frequency oscillator we use. In the ruby laser, we are using xenon flash lamp helically wounded over. And in the semiconductor laser, direct recombination of electrons and holes. And in the dye lasers, we are using the chemical reaction. So gain medium. Gain medium is the material, simply we can say that. Major determining factor of the wavelength of the operation of the laser, excited by the pump source to produce the population inversion, where spontaneous and stimulated emissions of photons takes place, and the medium may be either solid or liquid or a semiconductor. Now, the final one is the optical resonator. Simply, if we take a solid material, we can't produce the stimulated emissions. We need to enclose that gain medium in the case of optical resonator. So what is meant by this optical resonator means two parallel mirrors placed around the gain medium. Light is reflected by the mirrors back and forth into the medium and is amplified. The design and alignment of the mirrors with respect to the medium is crucial. Filling mirrors, modulators, filters, and absorbers may be added to produce the variety of effects on the laser output. So this is the simple construction of the optical cavity. Here we are having the medium enclosed with the help of partially and fully reflecting glass plates. So one reflecting mirror is at one end while the other end has a partially reflecting mirror for partial emission. You should remember always that the laser output is taken from the partial end. So remaining power reflects through cavity for amplification of certain wavelengths, a process known as optical feedback. Construction way is similar to that of the LEDs. So now this is the construction of the optical cavity. Then what happens inside that? This is the process that is happening inside the optical cavity resonator. So usually all the atoms are in the ground state. Now when you instant the external energy, means stimulated absorption, the atoms will go to the excited state. Now when the atoms are going to the excited state, from the excited state, they may spontaneously come down, and some of the atoms may come down due to the stimulated emissions. So like that, this is a continuous process. There are now stimulated emission at light along the laser axis. Then what happens means the emitted photons are not directly taken out. They are traveling between this partial and fully reflecting glass plates. So these are the glass plates, and this is the gain medium. It may be a solid or gaseous or a semiconducting material, but should be enclosed between the fully and partially reflecting glass plate. Now, once these photons are, when the atoms de-excite, the photons are released. These photons travel back and forth in between these two partially reflecting glass plates and fully reflecting glass plates. So these photons will continuously travel, and during this travel, some of the photons maybe spontaneously can be converted into the stimulated, means in phase with that of the other one here. So like that, the photons travel back and forth, and once this resonating length L is equal to n lambda by 2 condition is satisfied, such photons will be emitted as laser output from the partially reflecting glass plate. So these are all the requirements that are essential to produce the laser light from any of the medium. I'll repeat again. So which material is taken, either solid or gaseous or semiconducting material. Now, what is the pump source that is used to produce the to achieve the condition of population inversion, which is N2 greater than N1, with the main condition to produce the stimulated emissions that leads to the laser light. And irrespective of the medium, in order to produce these stimulated emissions to a particular amplified light, we need to enclose that medium in this optical cavity resonator. And once the resonating condition like L is equal to the length of the medium is equal to n lambda by 2, then that particular photons are taken as laser output. So these are all the requirements to get the laser light from any of the medium. Thank you.